Hello everyone, my name is Shalini and today I will be going to discuss the matter in our surroundings, that is of class 9th, and subject is science, specifically of chemistry. So the chapter's name is Matters in Our Surroundings. Firstly, I will make you remember and understand the concept of matter. What does a matter means? A matter is a substance which is occupying space and having a mass. Now quickly see around your surroundings and give me few examples. You can write it down in the comment section. What are the examples of matters? Anything in your surrounding which is occupying space and having a mass. It can be your pen, it can be your water bottle, it can be anything you can write in the comment section below. So your time is over. Now let me introduce with some of the examples which I have written here. That matter is anything which occupies space and has a mass, for example chair, chalk, air, milk, etc. Now, are you able to classify that these four examples are somehow different from each other? Can you distinguish these examples, that how are they different from each other? Think about it. So you see that chair and chalk are different from air and air is different from milk on the basis of their physical characteristics, that we see chair and chalk as a solid, air as a gas and milk as a liquid. But all of these are somehow occupying space and having a mass. You see a balloon filled with air and a balloon which is not being blown with air. Both have difference in their size. That means that air also occupies some space and it will be slightly heavier than this. So it will be having some amount of mass in it. So from here we understand what is the concept of matter. Now there are some basic classifications of matter. Firstly, according to the Indian philosophers. The Indian philosophers in their times said that matter is nothing but it is the Panch Tattva, the basic 5 elements, which was the air, earth, fire, sky and water. Air, earth, fire, sky and water according to the Indian philosophers. Now according to the science, we have classified it as two basic components. First will be the physical state and second will be the according to the chemical composition. First, the physical state, the matter was classified as solids, liquids and gases, which we have already seen in the examples, that how solid, liquids and gas are classified. How we can identify it is how we can identify the solid, liquids and gas will be discussed after some time. So the third point is on the basis of chemical composition, which means according to the composition of the matter, it was classified as pure substances and mixture. Now the pure substances and mixtures are in detail in the second chapter of class 9, so we will study there. But the basic difference between the pure substance and mixture is that pure substances are made up of only single type of atom or substance, whereas the mixture are the combination of two or different types of substances. So the pure substances may be elements or compounds. We know that elements in the periodic table, we have 118 elements, So they all are considered as pure substances, and compounds we take as H2O, CO2. These are made up of two different kinds of elements in different amount of ratio. So this will be studied in the next chapter, which is pure substances around our nature. Mixture may be homogeneous or heterogeneous. Again, homogeneous means the same amount or uniformly distributed solutions or mixtures is known as homogeneous mixture, and heterogeneous is non-uniform distribution of the matter. Means homogeneous, we can take an example of a lemon water or a milk and water solution, and heterogeneous you can take as if you take rice and you take wheat and mix both of them in a container, they will not be uniformly distributed. In each spoon you will get uneven distribution of wheat and rice. It may be 3 grains of wheat and 2 grains of rice. So this is an uneven distribution. And homogeneous, where the lemon water which is prepared, you taste the lemon water, every spoon, every drop of the lemon water will taste the same. So it is known as homogeneous and heterogeneous. Moving forward to the physical nature of the matter. So the physical nature of matters are, there are basic 4 points which I have written, 5 points sorry. Matter is made up of particles. The particles of matter are very tiny. The particles of matter have space between them. The particles of matter are continuously moving. The particles of matter attract each other. They have a certain amount of force of attraction between them. The first point, which is matter is made up of particles, is explained with the help of a simple activity which is written in the NCERT of your book, which is, take a glass, a transparent glass, and mark a level of water. Fill it with water and mark the level of water. Now add 1 spoon of salt or sugar to it and let it stir and get stable properly. After that, you will notice that no amount of rise in water has been noticed. Means the level of water, if the initial level of water was 5 ml, the final level of water is also 5 ml. So this means the particles of matter are very small and it is made up of the particles. Every particle in combination of each other gives a matter. The second property is the particles of matter are very tiny. Means the particles of matter are very tiny can also be explained with the help of an example again written in the NCERT book. We take 2-3 crystals of potassium permanganate, which is KMNO4, potassium K permanganate, KMNO4, in 100 ml of water in a beaker. So the potassium permanganate has a color of a slightly purple kind of thing, and if you dissolve it in 100 ml of water, the whole solution becomes somehow like this color. And now if we take 10 ml of the solution, which was 100 ml of solution, if you take 10 ml from it and add to another beaker having water, 100 ml of water, and again you repeat this activity same, you will see that there is a difference in the color from the first to the fourth beaker. What does it mean? It means that particles of matter are very tiny and it has millions of tiny particles in each crystals. Means it will not easily lose their color, it will not easily lose their properties that it is having its color, but it will with time and with with time and with further dilution, it gets it never loses its property, but it gets discolored a little. You can see that this is a dark purple kind of color and this is a baby pink color. This shows the particles of matter are very tiny. The third property is particles of matter have space between them. In activities 1 and 2, we saw that particles of sugar, salt, Dettol or potassium permanganate got evenly distributed in the water. Similarly, when we make tea, coffee or lemonade, particles of one type of matter get into the spaces between particles of the other. This shows that there is enough space between particles of matter. The first activity, which was of adding sugar and salt to the water, itself describes this, that the particles of matter are having space between them because there was no rise in the bar or the level of the water which was in the beaker or a glass. So this suggested that the particles of matter have space between them, and the extra substance or extra matter which we add gets evenly distributed in between the spaces, so that we get the same taste from the nimbu pani or the sugar water, you can say, and also we get the same smell in every drop of the water which is made from the Dettol water, or you can say the same color of the potassium permanganate, which got evenly distributed, means each drop or each spoon of water will taste same, smell same, and will look the same. So this was the third property. The fourth one says particles of matter are continuously moving. We can understand this with the help of an example, that if we take a beaker filled with water and we put few drops of ink in it, wait for some time, it will intermix with its own. The ink will be distributed in the water evenly. So what does this activity mean? This means that the ink spreads evenly throughout the water due to the movement of the particles of water and ink, which means the particles of matter is continuously moving, the particles of water is continuously moving, the particles of gases are also continuously moving. Solids is in the case of solid, this is not applicable because the particles are very tightly bound, and therefore and hence it has a shape of its own. We have already read in the junior classes that solids have a shape of its own and it does not get deformed easily because of the particles of matter are strongly attracted to each other. So this property, which is particles of matter are continuously moving, are generally seen in the liquid and gases. The next property is particles of matter attract each other. Now here we can see or take the example of a solid. Take an iron nail, a piece of chalk and a rubber band. So these are three different kinds of solid you can easily identify. An iron nail, it is very hard. You cannot break, you cannot cut it easily. But a piece of chalk, you can easily break it into two pieces. You can easily dissolve it in water. It gets evenly dissolved. A rubber band, again a different kind of solid. It gets stretched easily. It will not break, but it will get stretched. Try breaking them by hammering, cutting or stretching. It is more easier to break the chalk, less easier to break the rubber band, and very difficult to break the iron nail. This is because the particles in iron nails are held together with greater force than in the rubber band or chalk. So in the previous property itself, I have already told that the particles of matter attracting each other is a very strong force of attraction, which we can see in the case of iron nail. But why do we consider a chalk and a rubber band into solids then? Is there any kind of explanation? Yes, there is a kind of explanation which you will have to give me in the comment section below. Why do we consider a rubber band into solid? This will be your homework. Now the states of matter. There are three different states of matter, which is solid, liquid and gas. The first one is solid. Solids have a definite shape and a fixed volume. Definite shape and a fixed volume. It is obvious that solids are having a definite shape because each and everything you are surrounded with is having a definite shape and it will not change with time. Your water bottle, your pen, your chair, table are the examples of it. The space between the particles is minimum, and that's why the particles was not able to move, which we have studied in the properties. So here is the example of a brick, or you can take any example of solids. There are infinite number of examples of solid, and you will see that the particles having the space, space is very minimum, the space between the particles. The third property is the force of attraction between the particles is maximum. So in the case of solid, there is a very stronger force of attraction working on the particles. The fourth point is the movement of the particle is minimum. So the fourth point is the conclusion of the third point. If the force of attraction between the particle is maximum, then the movement of the particle will obviously be minimum. There are least compressible, means there are very less scope to compress the solids. If you compress it beyond their limitations, it will break but will not get compressed. The rate of diffusion is least. So diffusion means intermixing of two particles on its own. So the rate of diffusion is the least, means it will, if you see a solid, if you are seeing a solid in the year 2022, it will remain the same in 2025 or 2030, means there will be no diffusion or the least diffusion in case of the solids. So the second form of matter is liquids. There are examples of liquids like milk, water, alcohol, and lemon water, sugar water, salt water, and various kinds of acids, that is hydrochloric, sulfuric, nitric. These are all liquids. So the liquids we see have no definite shape but have a fixed volume. Means if you are taking milk from a milkman, he will give you a fixed amount of milk. If you are taking 1 liter of milk, it will measure 1 liter at a fixed volume, but it will have no definite shape. If you are taking milk in a glass, it will take up the shape of a glass. If you take milk in the vessel, a container which is having like this shape, it will take the shape of the container. So liquids are not having a definite shape but having a definite volume, and it takes up the shape of the container. The space between the particle is intermediate, means there will be some space between the particles, somehow greater than the solid but lesser than the gases. The force of attraction between the particle is intermediate. The movement of the particle is intermediate. They are less compressible, and the rate of diffusion is more than the solid. So the force of attraction will be definitely intermediate because there is only intermediate amount of space between the particles. and hence again the moment of the particle will also be the intermediate. They are less compressible, means you can compress a little amount of a little more than the solid. If you were compressing the solid, it was breaking, but liquids can be compressed and filled forcefully to a very intermediate amount of volume. Their rate of diffusion is more than the solids, means the solid, we have seen that there was no diffusion in case of solids, but in liquids, which we have already seen an example above, that if we were mixing ink into the water, there was an intermixing of particles between the liquids and the ink added. So there is the rate of diffusion which is more than the solid. Now the last state of matter, which is gases. Gases have no definite shape and or fixed volume, means there is no fixed volume or a definite shape of gases. It also occupies the space of the container, means if you put some amount of gas in a balloon, it will occupy the whole space which is in the balloon. It will get evenly pumped up if you put gas in a balloon. The space between the particles is maximum, means the space you can see here, one particle is here, one particle is here, so the space is the maximum in case of gases. They are most compressible and the rate of diffusion is more than the solids and liquids. Therefore, hence we can easily smell the fragrance of the incense sticks, which is known as agarbatti, or you can also smell the fragrance of the food which is coming from your kitchen, because of the diffusion of the fragrance in the gases which comes to our nose and we can easily smell it. So the rate of diffusion is maximum in case of gases than solids and liquids. Now scientists are talking about two more states which we have to study in a very short manner, you can say, not much in the 9th class. So the two states which we are talking about is plasma state and the Bose-Einstein state. Plasma state is nothing but it is the ionized gas, you can say, when the gas gets charged and the electrical energy flows through it. These particles are in the form of ionized gases having approximately equal number of positively and negatively charged particles. The fluorescent and neon sign bulb consist of plasma. Means if we heat solids, we get liquid. After heating liquid, we are getting gas. What happens after we heat or electrically charged gas? It will convert into ionized gases, means equal number of positive and negative charged particles will be evolving through the gases. Some of the examples are the fluorescent and the neon sign bulbs, which is consisting of a plasma. Lightning, solar wind, aurora, fluorescent light and nuclear fireballs are some of the more examples of a plasma state consisting of free charged particles. Now the last state is the Bose-Einstein state, and I will be finishing my video with the Bose-Einstein state itself. And in another part I will be discussing the various processes associated with the states of matter, what are the effects of temperature and pressure on the states of the matter. So the final state of matter is the Bose-Einstein state. Firstly, the name itself says Bose and Einstein, means This state was discovered by two scientists named S.N. Bose and Albert Einstein, which together worked to give the fifth state of matter, which is also written as the BEC. The BEC is formed by cooling a gas of extremely low density, about 100,000 the density of normal air, to super low temperature. Means gases are cooled. Gases, after cooled at very low temperature, at extremely low density, and to super low temperatures, about 100,000 the density of normal air. 100,000 the density of normal air. You can imagine how small the particles of Bose-Einstein's may be. So this state is known as Bose-Einstein state. Means gas cooled to a very super low temperature and to extremely low density. You can see it, it somehow looks like this. That's all for today. Thank you if you have watched my video up till here. Thank you very much. If you have any doubt, any query, any question regarding this video, you can ask easily in the comment section below. If I see, I'll reply it. And also, please try to understand the concept which I have tried to make you understand easily, and also the homework, that why the rubber band is classified as a solid if it is easily stretched to a certain amount of point. Thank you. That's all for today. Bye bye. Have a nice day.